So perhaps we can begin by rewriting the order of the equation. And then maybe what we can do is we can create a U-substitution. Let U equal, we're going to let U equal the argument, the stuff inside of the parentheses. So this becomes sine of U equals -1/2. Now think about it like this. That is going to be, U is an angle. And then recall that on the unit circle, sine is kind of like the y coordinate. So we want to go to an angle where at that angle, the y coordinate is that much. So I have an old unit circle here. It's really beat up. Check it out. At which angle here is the y coordinate -1/2? Examine it thoroughly, and you'll see that here and here, these y coordinates are what we want them to be, and the two angles are 210 and 330. But I think they want radians because they started with pi's. So we have 7 pi over 6 and 11 pi over 6. So this tells us that U is 7 pi over 6, or possibly 11 pi over 6. So that's how we find the value of U. But then remember that U equals this. So bring this stuff here and put that back in for U. So we have 2 pi plus theta equals 7 pi over 6, or 2 pi plus theta equals 11 pi over 6. Now subtract 2 pi from that, and you'll see that theta should be -5 pi over 6, or subtract 2 pi from that, and you'll see that theta could possibly be -1 pi over 6. Now look, I don't have the directions, so I don't know if they want the answer to be within a certain interval. If they want the answer to be like between 0 and 2 pi or something like that, then you'll have to add 2 pi to these angles to get them coterminal. If they want you to give all solutions, you might have to do something where you go something like plus or minus 2 pi k. I'm not sure what they want because I don't have the directions, but I'm assuming the goal was to solve for theta. And we have. U was just a temporary substitution, a temporary variable that helped us. But at the end of the day, these are the values of theta.